So hello friends, in this video we are going to cover the top 50 interviews question can be asked from MongoDB whenever you are going from your backend interviews, right? So let's start with this. So the first question that we have, that is the most common question, is explain the difference between SQL database and MongoDB, right? So let's say SQL database are the relational database where the data is stored in tables with predefined schemas, right? While in MongoDB is a NoSQL database, which means the data is stored in collections or the JSON-like documents without a predefined schema. Okay, so that's the difference between SQL and MongoDB database. So the next question would be, how does MongoDB ensure the high availability and horizontal scalability, right? So MongoDB achieve the high availability through the replication and horizontal scaling through the sharding. So replication involves the maintaining the multiple copies of the data across the different servers, while sharding involves the distribution of data across multiple servers. What is the indexing in MongoDB and why it is important? So indexing in MongoDB is the process of creating index to improve the query performance by allowing the database to quickly locate the data without scanning the entire collection. So indexing is important for speeding up the read operations and especially for frequently accessible fields, right? So the next question would be, how do you handle the schema migration in MongoDB as the application evolves? So schema migration in MongoDB can be handled by using techniques such as backward compatible schema changes and version documentations, and performing the data migration during the application updates. So one common approach is to use the migration scripts to update the data schema as needed. So the next question is, explain the concept of aggregation pipeline in MongoDB and provide an example for query. So here we have an example as, let's first explain what is aggregation pipeline. So aggregation pipeline in MongoDB allows you to process and transform the documentation using the sequence of stages. Each stage performs a specific operation on the input document and passes the results to the next stage. As an example, you can see here we have 4 different stages. Okay, so in first stage we had just making a query where we are checking that where the status is completed. So all that query that passes this situation the result will be passes to this. Okay, and here we are grouping by the customer and we are getting this total, and then total attribute will have this amount. So whatever the amount attribute we have in our previous documentation will now be get summed and will be stored in this total. Okay, and all these grouping were done by customers. Okay, so this customer group may have a different type of customers and all, right? Finally, we had sort this data. So we had sort this data based upon this total. So minus 1 indicates that as descending orders, right? And here we had finally put a limit. So for example, at a time we just want to only get 10 data, right? So we are only want to get only top 10 data, right? So it's from top 10 amounts orders that have highest amount, right? So the next question is, how do you optimize the MongoDB query for the performance? MongoDB queries performance can be optimized by creating the appropriate indexes and limiting the number of documents returning by using the projection and filtering, avoiding the large result sets, and use aggregation pipeline for complex queries. Okay, so basically it simply means that we have to make our MongoDB queries such that we should only query for those documents that is needed instead of getting all the data, right? So explain the difference between $in and $all operation in MongoDB, right? So $in operation in MongoDB is used to select the document where the value of the field is equals any value in a specific array. Okay, so that is why we are using .in, right? So if any value matches that from the array that we had provided, then we should go with $in, while the $all operators on the other hand select the documents where the values of the field contain all the values in a specific array. So if we had given an array and it contains 2 elements, then the respective elements where we are making the query should also contain both those elements in the query parameter, in the query object, query document, right? So the next question is, what are some common strategies for handling the pagination in MongoDB query? So pagination in the MongoDB can be achieved by using the techniques such as limit offset pagination, cursor based pagination by using ID fields, or by using skip limit methods. Okay, so we can go with offset pagination, either we can go with skip and limit methods, or we can using ID fields. Okay, it is important to consider the performance implementation of each approach, especially when dealing with the large database or large data set. Now the next question what we have is, how do you ensure that data consistency in MongoDB in a distributed environment? Okay, so data consistency in MongoDB can be ensured by using techniques such as writing concerns while specifying the level of the acknowledgement required from the MongoDB for writing operations, and transactions for multiple documentation operations. Additionally, application level logics can be implemented to handle the eventual consistency. Okay, so the next question what we have is, explain how do you handle errors and explain how would you handle errors and retires in MongoDB queries within our Node.js application. In Node.js application, errors and retires in retries. Okay, so our next question is, explain how you handle errors and retries in MongoDB queries within our Node.js application. So in Node.js application, error and the retries in MongoDB queries can be handled by using try-catch block or the error handling middlewares. For retrying fails operations, exponential backoff strategies can be employed to prevent the overwhelming the database server. Okay, so these are the approach which you can use. The second thing is, how do you ensure that security is in the MongoDB, and discuss some best practices. So securities in MongoDB can be ensured by implementing authentication, authorization, and encryption. So best practices including the enabling the access control and the authentication mechanisms such as SCRAM, that is salted changing the response authentication mechanism, confidential role-based access control, RRAB, to restrict the access to the database and the collection, and enabling the transport encryption by using SSL or TSL, and implementing the network security measures such as the firewall rules. Now the next question is, explain the concept of document embedding in MongoDB, and when is it appropriate to use. So document embedding in MongoDB involves the strong related data within a single document rather than using a reference between the separate documents. So it is appropriate to use document embedding when the embedded data is frequently accessed together with a parent document, and when the embedded data is relatively small in size. However, it is important to consider the potential impact on the document size and the query performance when using that query document embedding. Okay, so document embedding in MongoDB involves the storing related data within a single document rather than using the reference between separate documents. The next question is, discuss the difference between find and find one method in MongoDB. When would you use each? Okay, so the find method in the MongoDB returns the cursor for a set of documents that matches the specific query criteria, while the find one methods allows to return a single document that matches the query criteria. So the find method is used when you expect the multiple documents to match the queries and want to process them as a set, while the find one method is used when you are only need a single document or when you want to quickly retrieve the first matches document. Okay, how would you implement the text search in MongoDB? Okay, so the text search in the MongoDB can be implemented by using $text operator along with the text index in the field you want to search. For first, create a text index on the field using this db.collection.createIndex field equal to text, and then use that text operator in your query to perform the text searches. For example, as you can see here we have making a query. We are targeting the DB, which is article, and there we are finding our text query. Okay, our text. So here we are making a text search, and we are targeting this search keys in my database. Okay, and within this I am searching for MongoDB. Okay, so that's how we can make text search queries in MongoDB. Now explain the concept of the transitions in MongoDB, and when would you use transactions. So transactions in MongoDB allows you to perform multiple operations on multiple documentation as a single atomic unit of work. So you can use transactions when you need to ensure the data consistency across multiple documents or the collection, such as in financial transaction or the complex multi-document update. The transactions provide ACID, that is atomicity, consistency, isolation, and durability, guarantees ensuring that either all the operations within the transactions are appears or not, or none are applied. Right. So the next question is, how do you handle the data migration and seeding in MongoDB? So data migration in MongoDB can be handled by using tools such as MongoDump and MongoStore for exploring and implementing the data between database and the collection. I think I had misspelled something. So data migration in the MongoDB can be handled by using tools such as MongoDump and MongoStore for exporting and importing the data between database or collection. For seeding initial data, you can write script or use the library like faker.js to generate the sample data and insert it into the database during the application initialization. Okay. Now the next question is, discuss the importance of schema design in MongoDB and what factor influence the schema design decisions. So schema design in MongoDB is crucial for performance, scalability, and data integrity. Factors influencing the schema designs decisions including the nature of the data, query parameters, read versus write performance considerations, and the need for flexibility or the data consistency. Denormalization and embedding and reference patterns are some of the strategies used in the schema designs to optimize the query performance and data access pattern. Now the next question is, how do you monitor and optimize the MongoDB performance in production environment? In MongoDB the MongoDB performance can be monitored by using tools like MongoDB Compass, MongoStats, MongoStop, and the MongoDB Enterprise Monitoring System or the service. Key performance metrics to monitor including the query performance, index uses, disk uses, and server resource utilization. Performance optimization technique including the index optimization, query optimization, and hardware scaling and sharding. Discuss the strategy for handling backups and disaster recovery in MongoDB. So backup and the disaster recovery in MongoDB can be handled by using techniques such as regular database backups, replication for the data redundancy, and the fault tolerance, and automated failovers to secondary nodes in the case the primary nodes fails. Additionally, you can leverage the cloud-based backup solution or the MongoDB Atlas for managing the backups and disaster recovery capabilities. Okay, so the next question is, how do you handle the data consistency issue in the MongoDB distribution environment? So data consistency in distributed MongoDB environment can be ensured by using techniques such as write concerns level to control the acknowledgement behavior of write operation, read preference settings to control the consistency of the read operations, and transitions for maintaining the data consistency across the multiple document or collections. Application level data can be empowered to handle the eventual consistency and confident resources. Now the next question would be, explain the concept of TTL, time to live index in MongoDB, and when would you use TTL index? TTL index in MongoDB are special index that automatically delete document from the collection after a certain amount of time. So TTL index can be created by using expire after time seconds options when defining the index, right? So let's go to our next question, that is discuss strategies for improving the MongoDB query performance in application with large dataset. So strategy for improving the MongoDB queries performance in application with large dataset includes the creating appropriate index to support query patterns, optimizing query to use covered queries where the possible, utilizing the aggregation pipeline for complex operations, implementing the data partitioning and shading to distributing the data across multiple nodes, and denormalizing the data to reduce the need for joins and multiple queries, right? So the next question here we have is, how do you schema evolution and the backward compatibility in MongoDB can be managed by using strategies such as versioning document, providing the default values for the new fields, using flexible schema designs such as dynamic schemas or the schema less documents, or implementing the migration script to converts to the updated existing data when the schema changes occurs. Okay, implementing the migration schema or converts to the updated existing data when migration changes occur, right? So explain the concept of changing stream in MongoDB and how would you use changing stream in real world application. So change stream in MongoDB allows application to subscribe to the real-time notification of changes to the data in a database. They provide a reliable and efficient way to implement the features such as real-time update, notification, and event-driven architectures. Change stream can be used in real-world application to trigger the actions and update in response to data changes. Synchronous data across the different services and microservices, or the implement the collective features such as chat application or live database or dashboards. Now the next question here we have is discuss the impact of read and write concern on MongoDB performance and the data consistency. Read and write concerns in MongoDB control the acknowledged behavior of the read and write operations respectively. Read concerns determine the level of consistency required for reading operation, while the write concern determine the level of the acknowledgement required for the write operations. Choosing the appropriate read and write concerns is essential for balancing performance, consistency, and durability requirements in MongoDB application. Higher consistency and the acknowledgement levels may increase the additional latency and the overhead, but provides a strong guarantees of data consistency and durability. Now the next question is, how do you implement the authentication and authorization in Node.js application using MongoDB? So authentication and authorization in MongoDB is by using MongoDB can be implemented by using the libraries such as passport.js for authentication and JWT web token for authorization. Okay. So user credential can be stored by securely in MongoDB by using bcrypt for the data hashing, and role-based access, that is RBCA, can be enforced by storing the user role and the permissions in a database and implementing the middleware to restrict the access to certain routes or the resources based upon the user roles. Now explain how would you handle the database migration and schema changes in production MongoDB environment without downtime. Okay, so database migration and the schema changes in the production MongoDB environment can be performed without downtime by using techniques such as rolling update, blue-green deployment, canary release to gradually apply the changes to the database servers while maintaining the availability. Additionally, you can use the strategies such as backward compatible schema changes, versioning documentation, or implementing the feature flag to control the rollout of changes and minimize the impact on users. Now, the next question here we have is, how do you diagnose and troubleshoot performance in MongoDB? So to troubleshoot the performance issues in MongoDB's queries involves analyzing queries execution plans, identifying slow queries using tools like MongoDB profiling or the monitoring utilities, examining index uses and the query patterns, optimizing the queries by using explain, and adding and addressing the common performance bottlenecks such as insufficient indexes and effective data scans or the insufficient query patterns. Now the next question is discuss the impact of the data modeling decisions on query performance and scalability in MongoDB. So data modeling decisions in the MongoDB have a significant impact on query performance and scalability. Factors such as document structure, indexing strategies, data access patterns, query complexities influence the efficiency of queries and the scalability of the database. Proper data modeling techniques such as denormalization, embedding, and reference patterns can be employed to optimize the query performance and support the scalability requirements of the application. Next question is, how do you ensure that data integrity and consistency when performing multi-document transaction in MongoDB? So data integrity and consistency in MongoDB transactions in MongoDB are ensured by the ACID, atomicity, consistency, isolation, and durability guarantees provided by the wide trigger storage engine. So MongoDB transactions supports the operation across the multiple documents and the collection within a single session, ensuring that all the operations within the transactions are applied or none are applied. By using the transactions, you maintain the data integrity and consistency across the related documents, even in distributed MongoDB environment. Now, the next question here we have is, how would you construct a MongoDB query to find document that matches the multiple criteria such as range of values and a specific field, right? So here we have an example. To construct a MongoDB query that matches the multiple criteria, you can use AND operator along with the other queries. For example, to find the document where the age field is in between 25 and 35 and the gender field is male, you can use the following queries as we had firstly defined db.collection.find, and there we are using this AND operator, and within this AND operator we are giving an array, and within this array we had created the multiple queries. So as in our case, that age should be greater than 25 and less than 35 is our first query, and the gender should be male, right? So the query will returns the documents where the age field is greater than or equals to 25 and less than or equals to 35, and at the same time gender field should be male, right? Now the next question that we have is, how do you construct a MongoDB query to perform the case sensitive search for a document containing the specific string within a text field? Okay, to perform a case sensitive search for the document containing a specific string with a text field, we can use regular expression with the regex operation or with the regex operator and the options modifier, that is I, for the case sensitive operations, for the case sensitive queries. For example, to find the document where the name field contain the string John, regardless of the case, you can use the following like as regex, and we are using this I, this I symbol. So this I symbol will give us the ability that okay, either this should be in capital or small letter, maybe anything. Okay, so the query will return the document where the name field contain the string John in any case, right? So we had just built the query like db.collection.find, and then finally we had make our query. Now explain how would you construct a MongoDB query to search for the document based on the nested fields or array. Okay, so let's say if here we have a field which is a string, okay, which is an array, right? So to construct a MongoDB query to the search for a document based on the nested field or the array, you can use the dot notation to simplify the nested field or the array element. For example, to find the document where the address.city field is New York or the tag array contains the string MongoDB, you can use the following query. So here we are using this or, either this will satisfied or either this will satisfied, and here we are making our query as address.city. So here we have this address object, and within this address object we have this city attribute. So the city should be New York. So that's how we are making the first, and there we are making a second. So either if any of them are met, it will return us the document. So the query will returns the document where either the address.city field is the New York or the tag array contains the string MongoDB. Okay, so how do you construct a MongoDB query for searching document based upon the nested fields or array? Okay, so these are the types. So as even though if let's say this tags field is an array, right? So this tag array, within this tag array we are finding if within this array if MongoDB if this MongoDB of string is exist or not, right? So the next question is, how would you construct the MongoDB query to perform the fuzzy search for the document based on a partial matching of the field values? So the answer: to perform a fuzzy search for the document based upon the partial matching of the field value, you can use that regex operator for the regular expression that includes the desired substring. For example, to find the document where the title field containing the substring MongoDB, we can use this. Okay, this title, and the query will returns the documents where the title field containing the substring MongoDB in any case, right? Now the next question here we have is discuss the process of constructing a MongoDB query to perform aggregation operations such as grouping, sorting, projecting fields, right, and all. So aggregation operation in MongoDB involves the constructing of pipeline stages, each performing a specific operation on a grouping as a grouping and sorting, projecting fields, and applying the aggregation function. To construct a MongoDB aggregation query, you can use aggregate, right, and aggregate method, and with an array of pipelines stages. Each stage specify a transformation or the operation to be applied to the input document, and for example to group document by the category field, and to calculate the total count of each category, you can use the following aggregation pipeline. So here we are grouping firstly, so all the documents will be grouped by the category first, right? And so for grouping we are using this id field, and so the value of each group, so let's say in the category we have 3 types of category, right? So we have total 3 different tables. Okay, 3 different documents will be created from this, and here which contains an attribute which is total, and total gives the sum of all. Okay, so here we have this sum, and we are giving this 1. Okay, so the next is we are sorting this. So sorting means we and where it's within this total, so we are targeting this total. Based upon this total, we are trying to sort the documents received from this query, right? And finally we sort in decreasing order by using this -1. We are saying that sorted into from highest to lowest, right? And then finally we are using this project. So within this project category, we are basically creating a document where we are specifying that okay, the total equals to 1 and that id equals to 0. So basically if I just want to return the document that only contain this total field, and it should not contain this id field. Okay, so that's why I had represented here this 0, and we are targeting with this id. Okay, so that's how we had created this query, and this aggregation pipeline will group the documents by the category fields and calculate the total counts for each category, sort the result in a descending order, and that means top to bottom, and the project the category and the total count field in the output document, right? Okay, so how do you construct a MongoDB query to perform join like operation between the 2 collection? Okay, so you can use this lookup in aggregation. So let's say MongoDB does not supports the transitional SQL style joins, right? So but you can achieve the similar functionality by using lookups aggregation stage, and this stage allows you to perform the left outer joint between the 2 collections based upon the common fields. For example, to join the document from the order collections with the document from the customer collection based upon the customer ID field, you can use this following aggregation query. So we are just joining here these two fields. So here we are targeting, so here we are making query in our order document. Okay, and within this order documents we are targeting our customer. Okay, and so we are targeting our customer. So here we have this documents models. So here we have this document data orders database, so not database but orders documents and orders collection, and here we have our customer collections. Okay, so because of within this orders collection we had maintaining a field with the name of customer ID, and where we had assigning the IDs of the related customer fields, the related documents present in this customer collection, right? So here we are specifying as a local field of our customer ID, and then as a database from where we are going to fetch the data. Here we are mentioning that we should go with lookup to customer collections, right? And then finally we are giving the reference that which field does it should be compared with. So within this origin field we had given this. Okay, within this customer document you will find an ID field. Okay, so you have to match the ID field with the ID which I am providing here at customer ID, right? So then I had finally output this result as a customer details. Okay, so the whole query will be giving me a customer details documents, and then customer details document have all the details. So instead of showing me now this customer ID, it will show me a new field with the customer details, and within this customer details we have all the collections respective to this customer ID. Okay, and directly consuming all these documents from this customer collection. Okay, so this query will returns the documents from the order collection with an additional fields called customer details containing the area of the matching documents from the customer collection. Right. Now the next question is explain how would you construct a MongoDB query to perform the geospatial queries such as filtering document within a certain distance of a given location. Okay, so MongoDB supports the geospatial queries using the not geospatial but geospatial indexes. Okay, so how do you construct a MongoDB query to perform geospatial queries such as finding documents within a certain distance of a given location? So MongoDB supports the geospatial queries by using geospatial indexes and the operations such as geonear and geowithin. To construct the MongoDB query to find the document within a certain distance for a given location, we use geowithin, and you first needed to create a 2D space index on a location field, and then you can use the geonear operators to perform a geospatial query. For example, to find the document within the 5 km of a given latitude and the longitude, you can use the following query. So here we are making an query by using this aggregation method, and within this aggregation method we had created this array, and within this array we are giving this query, and here we are using geoneer, and here we are giving this point type equals to point. Coordinates we are referring here as longitude and latitude. Here we are providing these, and finally we are referring that we should measure the distance, and here we are giving this maximum distance is 5000, that means 5 km, right? And its endings, and here we are specifying that by which measures you are going to take the distance. So that should be spherical, and that's is why we are referring here true, right? So the query will returns the document from the place collections that are within 5 km of specific latitude and longitude. Now the next question here we have is to discuss the process of constructing a MongoDB query to perform the text searches operations on the text indexed field. Discuss the process of constructing a MongoDB query to perform the text searches operation on a text index field. So MongoDB supports the text searches operations on a text field by using text operator. So we can simply use this text operator, and to construct the MongoDB query to perform the text operator, we can first need to create a text index on the text searchable field, and you can then write this text operator in your query. So here we have this text operator, for example, to find the document containing the word MongoDB in the content field, okay, in the content field, and you can use the following query. Okay, so here that says how we can make this query. So this query will returns the document from the articles containing whether the content field contains the word MongoDB or not, right? Where the fields contain word MongoDB or not, right? So the next question is, how would you construct a MongoDB query to perform the date-based operation, such as finding documents created within a certain time limit or certain time period? So to construct a MongoDB query to perform the date-based operation, you can use the date comparison operators such as GTE or LT. For example, find the document creating within the 7 days, so you can use this query. For example, created at, you are targeting the field, and within this field, let's say we had making a query like db.post.find, and here we are making our query at created at, we are making this query, and that should be greater than new.date, and within this date we are making this query, that is that new date whatsoever minus 7 into 24 into 60 into 60 into 1000. Okay, so finally we had convert this into seconds. Okay, and we go to the back date. Okay. So here we had created a back date from now 7 days ago, and then we are getting the data, the date which is a back date 7 days ago, and now we are making a query that this that created at should be greater than this date, right? So this query will return the document from the post collection where the created at fields is greater than or equals to the current date minus 7 days, right? So now constructing a MongoDB query to perform the wildcard or pattern based search on string fields, right? So MongoDB supports the pattern based searches using regular expression. You can use regex operators to construct a MongoDB query to perform a wildcard or the pattern based searching. You can use this regex operator with the desired pattern. For example, to find the document within the title field starts with the letter A, you can use the following query. So for example, here we are giving that it should be start with A, so this symbol is responsible for start with, right? And here we are making this regex query. Okay, so the title that start with A should be returned in this query, right? So the query will return the documents from the book collection where the titles field started with the letter A in any case. Okay, in any case, right? So the next question is, how do you construct MongoDB queries, MongoDB aggregation queries to group documents by fields and calculate the count of the document in each group, right? So to construct a MongoDB aggregation queries for grouping and counting the documents, you can use the group state to along with the some aggregation operators. For example, to group the documents from the order collected by the status field and calculate the count of the document in each status, you can use the following aggregation. So here we had this making and grow on db.orders.aggregate, and within this we have an array, and within this array we are making this query by using this group state, right? So by using this group state we are targeting we are grouping all documents by their status. Okay, and we are making a count variable, and this will basically add give me the counts of all the documents in each documents. Okay, so that's how it gives me the count, right? So this query will return a document with an id field containing the distance distance status values, and the count field containing the counts of the orders in each status. Now the next query, next question here we have is, discuss the process of constructing a MongoDB aggregation query to calculate the average values of numeric field across document. I'm going to repeat a question. Discuss the process of constructing a MongoDB aggregation query to calculate the average value of a numeric field across documentation. Okay, so to construct a MongoDB aggregation query to calculate the average value of the numeric field across documentation, you can use the group stage and along with the average aggregation operator, right? And for example, to calculate the average price of the product in the products collection, you can use the following aggregation as db.product.aggregate, and within this here we have an array and where we are creating our group state to perform this aggregation. And here we are mentioning that we are not targeting by groups by any fields name. Okay, so that's why we are referring here is id as null. And finally we are just willing to know the average price. Okay, so this average price will go through all the documents and do an average of all the prices, and that would be saved as average price. And finally we will get a document where we have the detail of average price, right? So this query will returns a single document with an id field set to null and the average price field containing the average price of the product across all documents, right? So, okay, so now the next question here we have is, how would you construct a MongoDB aggregation query to find the maximum and minimum value of a numeric field across documents, right? So to construct a MongoDB aggregation query to find the maximum and minimum value of the numeric field across document, you can use the group state along with the max minimum aggregation operators. So the question is, how would you construct a MongoDB aggregation query to find the maximum and minimum value of the numeric field across documentation? So to construct a MongoDB aggregation query to find the maximum and the minimum value of the numeric field across the documentation, you can use this group state along with the max and minimum aggregation operators. For example, to find the maximum and the minimum price of the product in a product collection, we can go with the following queries as db.product.aggregate, and here we are just using this group stage, and within this we are specifying that we are not grouping anything by any field name, right? So that's how we are giving this null. And then finally we are targeting the maximum price and the minimum price. So what would be the maximum price? So here we are targeting this maximum field, so the price field. And next we are asking for what should be the minimum price, right? So here we have this minimum price, and it will make a check on the price field that the minimum value for the minimum value, right? And this query will returns a single document with an id field set to null and the maximum and minimum price field containing the maximum and minimum price of the product across all the documents and respectively. Now the next question here we have is, discuss the process of constructing a MongoDB aggregation query to sort the document based upon the field values in ascending or descending order, right? So to construct a MongoDB aggregation query to sort the document based upon the field value, right? So you can use the short stage, and for example, the sort document for a student collection based upon their score, and the fields is in descending order. So you can get the student which has scored higher at the top, and in a same manner will get the student which secure the lowest will be at the bottom, right? So here we are making the query db.students.aggregate, and here we are making our query, that is that here we are using that short stage and state, and then finally we are making a query with short, and we are giving this -1 that will be decreasing descending order, right? So this query will returns a document from the student collection sorted based upon the score field in the descending order, right? Here the next question is, how would you construct a MongoDB aggregation query to limit the number of the document? So we do use a limit state, right? So by using this limit state we can perform the limitation, like we just only want the first 10 documents, we just want to only get the first 10 documents, right? So discuss the process of constructing a MongoDB query to unwind an array field and creates the separate document for each element. So to construct a MongoDB aggregation query to unwind an array field, you can use this unwind state, and the state deconstructing an array field from the input document and output one document for each element in an array. For example, to unwind the tags array field in the document from the article collection, you can use the following aggregation query. Like we are making a query on the aggregation, maybe this tags field is an array, but now we are just creating as many numbers of articles for each tags in this array, right? So we can simply use this unwind stage to do this, right? So this query will return the separate document for each element in the tag array field. Now the next question is, how would you construct a MongoDB aggregation query to perform a lookup operation and manage the documents from two collection based upon the common fields? Now I'm going to repeat this question once again. How would you construct a MongoDB aggregation query to perform a lookup operation and manage documents from two collection based upon the common field? So construct a MongoDB aggregation query to perform a lookup operation and managing the documents from two collections. You can use this lookup stage, right? And this stage performs a left outer join between the code documents from the inner collection and the documents from the secondary collection based upon the common field. For example, to migrate the document from the order collection with the document from the customer collection based upon the customer field, here you can make an aggregation query like this. Like say here we are using this, we are just making an aggregation query on orders fields on order collection, and we are referring this from where we should make this aggregation, right? So we should get the data from this customer collections, and on which local field I am referring the ID of these customer document. So here is the field, that is my local field, which is the customer ID, and finally which is the origin field which I am looking to in my customer document. So that field would be ID -ID and as an. So when I am referring this as, so a new field will be created with the name of customer details, and all the data received from this customer documents will be stored in this customer details. So this query will return a document from the order collection with an additional field of customer details containing the matched documents from the customer collection. Now the next question is, discuss the process of constructing a MongoDB aggregation query to perform a match operation and the filter operation based upon the specific criteria. To construct so I'm going to repeat this question. Discuss the process of constructing a MongoDB aggregation queries to perform a match operation and a filter operation based upon a specific criteria. To construct a MongoDB aggregation to perform a match operation and a filter operation, you can use this match stage, and this stage filters the input document based upon the specific criteria. For example, to filter the document from a product collection where the price field is greater than 100, and you can use the following aggregation query. Here you are using db.products.aggregate, and within this we are making an array, and within this array we have different stages. Okay, so the first stage is match. So here we are just making a query to the price field, and within this price field we are just referring that all the prices that is greater than 100 should be returned in this query, right? So the query will return the document from the product collection where the price field is greater than 100. Now the next question is, how do you construct a MongoDB aggregation query to perform a project operation and includes or exclude the specific field from an output document, right? So to construct a MongoDB aggregation query to perform a project operation and includes or exclude the specific field from the output document, you can use project stage, and this stage reshapes the document in an output by including or excluding the specific field. For example, to include only the name and the age field from the document in the students collection, you can use the following aggregation query. Let's say we are just making an API and request and queries to students collection, and to each document I am just interested in only two fields. Okay, so the name and the second one is age, And finally, let's say we have another field which is ID. I am not interested in this, so I had made this 0, right? So now the query will return a document from the student collection which only contain the name and the age field, including in this output. Okay, so output will only contain the student fields, but with only two fields, that is age and name, and we had achieved this by using this project stage, right? So the next question is, discuss the process of constructing a MongoDB aggregation to perform a group operations and calculate the aggregate value for grouping for group documents, right? So how we can group the documents. So to construct a MongoDB aggregation queries to perform a group operations and calculate the aggregate values for the group document, you can use this group stage, and the stage document, the stage group input document by the specific expressions or the calculates aggregate value for the each group, right? For example, to group the document from the sales collection by month field and calculate the total sales amount for each month. Okay, so we can do this by this query. So let's say we are just creating a db.sales.aggregate, and here we are just creating our array, and within this array this is our first query, right? So this is our first query or the first stage, and within this stage I had used this group stage, and within this use stage I am just targeting this month field. Okay, so as an ID I am giving as month, and here I am referring, so I am just targeting the date. Okay, so it is a date, so here we are targeting this date field, and that would be referred as month, right? So now total sales we are calculating is by using that sum, and within this sum we are giving this amount, right? So we are basically sum all the amounts. Amount refers to that amount field, sum all of the amount and save as the total sales. Okay, so this document will basically returns so the query will returns a document with a field of ID, okay, that is set as the month, and the total sales of the field containing the total sales amount for the each month, right? So that is how this is going to give us the value. Okay, so I think this is all about these top 50 questions that you may have asked if you are planning for Node.js interviews, and particularly from that backend if you are using MongoDB. Okay, so let's meet you in our next video. Till then, have a nice day and goodbye.